Welcome to Integrated Science Intervention Program for Senior High Schools. The topic for today is mole concept. The lesson title is Introduction to Mole Concept. I am Esiama Kufuor, your facilitator. What do these terms have in common? A pair of trousers, dozen of oranges, crate of eggs. You have 10 seconds to figure out the answer. Welcome back. You will agree with me that these are all terminologies that are used to represent or specify a specific number of items. A pair represents the number 2. A dozen represents the number 12. Crates of eggs represent the number 30. What is the relationship that exists between these terms and a mole? The answer to this question will be known in the course of the lesson. In this lesson, we are learning to define a mole of a substance. Then we'll perform calculations using the mole concept. The lesson has been structured into 3 sections. Section 1, we will be looking at the definition of a mole. In section 2, we will look at the mole as a unit of measurement. And in section 3, we will calculate the number of moles of a substance. The key words in today's lesson are mole, amount of substance, elementary entities, Avogadro's number or Avogadro's constant. Let us begin with the definition of a mole of a substance. Now, just as in everyday life, we use terms like pair to represent the number 2. We use a dozen to describe 12 items, and a crate of egg to represent the number 30. Scientists also use a mole to specify a certain amount of substance. So 1 mole of every substance contains a specific number of particles. What is this number? 1 mole of every substance contains 6.02 times 10 raised to the power 23 particles or entities or elementary entities. In science, when we say a particle, what do we mean by that? It could be atoms, molecules, ions, depending on the building units of that substance. So for example, if I take 1 mole of sodium metal, as you can see on your screen, and I count the number of sodium atoms, because sodium is a metal and it is made up of atoms. If I count the number of sodium atoms 1 by 1, I will arrive at the figure 6.02 times 10 raised to the power 23 atoms of sodium inside it. Similarly, if we have 1 mole of water, as you can see on your screen, water is made up of molecules. If I count the number of molecules, I will arrive at 6.02 times 10 raised to the power 23 molecules of water inside it. Is this the definition of a mole? Certainly not. Scientifically, 1 mole of a substance is defined as the amount of substance that contains as many elementary entities as there are atoms in exactly 12 grams of carbon-12 isotope. Complex definition, isn't it? Now, let me break it down into 2 parts so that it becomes easy for us to understand. Now, if you take 1 mole of a substance and you count the number of elementary entities, that is the number of particles present in it, the figure that you will arrive at is equal to weighing 12 grams of carbon-12 isotope and counting the number of particles present. So, the number of particles in 1 mole of any substance is equal to the number of atoms in 1 mole of carbon-12 isotope. So carbon-12 isotope is a reference scale for defining a mole. Let us turn our attention to a mole as a unit of measurement. And let me ask, how will you determine the number of particles of a substance contained in a given number of moles? Let's go through this exercise together. Now, if I give you 1 mole of any substance, how will you determine the number of particles present? This will be done by multiplying 1 by 6.02 times 10 raised to the power 23. Similarly, if I give you 2 moles of a substance, how will you determine the number of moles? Correspondingly, you have to multiply 2 by 6.02 times 10 raised to the power 23. Now, let me ask you, if I give you n moles of a substance, how will you determine the number of particles present in it? Similarly, this one will be done by multiplying n by 6.02 times 10 raised to the power 23. And that will give you uppercase N, as you can see on your screen. Now, let us extract the latter part of the derivation, and it will give us the expression on your screen. Now, let me ask, how will I make the lowercase n the subject of this expression? You will agree with me that we will have to divide both sides of the equation by the number attached to the n, or the number that is multiplying n. And that is, we have to divide both sides of the equation by 6.02 times 10 raised to the power 23. And the result is the expression you see on your screen. Now, you will see that we have 6.02 times 10 raised to the power 23 occurring as numerator and as denominator in one part of the equation. And so we can cancel them out. And when we cancel them out, the formula or the expression is reduced to lowercase n is equal to uppercase n divided by 6.02 times 10 raised to the power 23. Now, 6.02 times 10 raised to the power 23 is termed Avogadro's number or Avogadro's constant, and is denoted by uppercase L, and named after a famous scientist whose picture is on your screen, called Lorenzo Avogadro. Uppercase L is a molar quantity. When we say a molar quantity, what do we mean by that? It's a quantity which is expressed per mole. So if I substitute uppercase L into the formula, then I will arrive at lowercase n is equal to uppercase n divided by L, where lowercase n is a fundamental physical quantity called amount of substance, and its unit of measurement is mole, and the symbol for mole is MOL. And uppercase N is a number of particles or number of entities, and L is Avogadro's number expressed as defined particle per mole. This is the mathematical definition of a mole. Let us see how we can use this formula to solve a question. So take your pens and paper and solve this question. Calculate the number of moles contained in 8.0 times 10 raised to the power 23 molecules of neon, given that uppercase L is equal to 6.02 times 10 raised to the power 23 molecules per mole. You have 20 seconds to present your work. Welcome back. Let us see how you should have solved this question. Now, in integrated science, when you are given a problem question, I will encourage you to use the problem-solving strategy. It involves 3 steps. These are analyzing the question, solving it, and evaluating your answer. How do we analyze the question? We analyze the question by identifying all the quantities that have been given to you in the question and extracting them and listing them as the known quantities. Then you ask yourself, what is the quantity being sought for? And you list that as the unknown. Then the next step of the analysis is to find out the relationship that exists between the known quantities and the unknown. And that will help you decide on the correct formula that you will use to solve the question. So in this question, we were given uppercase N to be 8.0 times 10 raised to the power 23 molecules. Then we were given uppercase L to be 6.02 times 10 raised to the power 23 molecules per mole. And the quantity being sought for is lowercase n. So the next step is to state the formula that will enable us to solve the problem. So by definition, n is equal to the number of entities divided by Avogadro's number. So if you substitute the values, we'll get the expression you see on your screen. Now you realize that the numerator and the denominator of one part of the formula contains molecules, so they can cancel out, and we'll get our final answer to be N is equal to 1.33 moles. Now when we cancel the molecules, then it will be left with 1 over per mole. And in maths, if you have 2 fractions dividing, we usually write the denominator as multiplicative inverse, and that is how we arrived at the mole. The last stage is to evaluate your work. And how do we evaluate your answer? We evaluate our answer by checking to see whether you have not omitted the unit of measurement. We evaluate our answer by checking to see whether you have given the correct unit to the answer. Note that omission of the unit attracts penalty, or wrong unit also attracts what? Penalty. Again, you can also check your answer or evaluate your answer by using an alternative approach to solve the question. And the figure that you arrive at, you use it to validate your answer. All too soon, we've come to the end of today's lesson. What have we learned today? We learned that mole is the unit of measurement of amount of substance. We also learned that the number of moles or amount of substance that contains the same entities as there are atoms in 12 grams of carbon-12 isotope is what we call a mole. I'll leave you with some exercises to try your hands on. Question 1. Calculate the amount of substance contained in 1.5 times 10 raised to the power 20 magnesium atoms, given that L, which is Avogadro's number, is equal to 6.02 times 10 raised to the power 23 atoms per mole. Question 2 is a challenge question, and it reads, calculate the number of molecules contained in 0.8 moles of nitrogen gas, given that L, which is Avogadro's constant, is equal to 6.02 times 10 raised to the power 23 molecules per mole. In our next lesson, we will look at the relationship that exists between number of moles of a substance and its mass. Thank you for